bit of an awkward setup here. We'll wait for another maybe 5 minutes, start at 12:10. How many of you installed the first camera, USB camera package? Okay. Yeah. How many of you did the RealSense, the second one? Okay, and then third LiDAR package? So most of you have, okay, that's good. Awkward silence. Did you guys like start deciding on your projects yet?
Yeah.
Okay. So you informed Liang about the projects, or is that happening this week?
I already put one. We probably need to be discussion board on that. We have to tell. I'm there for it. Yeah, I heard from that.
Discussion board on UTS Online?
Yeah.
Okay, so let's begin. So what I'll first do is I'll take like 10 minutes and show everyone what the sensors can do. So we are discussing 3 sensors today. One is a regular camera. So most of you at home can still be able to do this if you have a webcam on your laptops or a separate web, like a USB webcam. So hopefully everyone can actually try this part at home. So the real I will provide ROS bags. So there is already a ROS bag for RGBD sensor under tutorial 3. So you can use that to try out basically tutorial 3 question 2. And then as far as the LiDAR is concerned, there is no ROS bag uploaded yet, but today I'll get one of the students here to record a quick ROS bag. And I'll show you how to record ROS bags as well, which I think might be helpful. And then I'll upload that by the end of today's class. So you can try the last question separately at home. Okay, so this will also give you a bit of experience on how to set up a typical ROS package, right? So if you guys remember the ROS session that I had with you, I told you that you have different nodes that help you interface with different sensors or do different types of processing, right? So there are a couple of ways. So basically you can write your own node using C++ or Python, or you can use nodes that other people have written, which is what's great, right? Say, for example, if you want to interface with the RealSense, there's an official ROS package developed by the people at Intel, plus basically the open source community. And if you want to, you can also contribute to that. My mask off a bit. It's hard to read. Yeah, so today we'll be learning about how to different ROS packages. So there's generally two ways you can do this. You can basically download the source code from GitHub, because all of these ROS packages are generally open source. So you can download them from GitHub, where they'll be constantly basically being updated by the community, right? So there's different versions generally, and people are constantly bug fixing and updating it. The second way is you can use the Ubuntu. So the last LiDAR package, I've shown you how to do that as well. So some of the official packages that are stable get put up on the official Ubuntu DPN package list. So in which case you can just download it and set it up in one command, right? But the first two questions, we are learning how to download from GitHub and build it from the source code itself, right? And generally you build it in what we call a Catkin workspace. So that is you're kind of building it in a isolated building environment, right? So it doesn't really affect the rest of your system. So if something goes wrong, it's self-contained in this folder called Catkin workspace, right? So it's a build environment, right? So this is what it looks like. So you just create a folder called Catkin workspace. You can name it whatever you want actually, right? And then you need a source folder where you would put basically all your source code. So for example, let's look at a typical ROS package. So this is something I wrote for my project. You can have launch files and source code for that. So you'll have basically, for example, either Python code like this or C++ code, right? So yeah, so if something goes wrong here, it doesn't affect the rest of your system, right? So you can kind of isolate it, and if something goes wrong, you can just simply delete it from here and nothing is going to really mess things up, right? So another advantage of this whole thing being in the open source community is you get to download this, you get to edit it if you want to change things, and then you can contribute back to the community, right? Which is how things kind of develop and progress. All right, so let's start with a simple example of the camera. So you navigate into your camera space, right? So hope everyone can see this. So you go to your Catkin workspace, your source folder, right? And then what you need to do is clone the GitHub repo, right? That has been given here. So you can just say git clone and you give the URL of the GitHub repo, right? So what it will do then, it will download that GitHub repo to your Catkin workspace, right? So if you actually want to see the GitHub repo, you can just follow this link, right? So let me actually show you what that looks like. By the way, this might be super basic for some of you as well, if you've done this kind of thing, but I'm just doing this for and in case there are people who are not aware of these things. Right, so this is what the GitHub repo looks like. So it's all your source code and all that stuff. Usually they give you a README with instructions as well. So afterwards, what you do is when you type in this command, what? I don't know what that's about. Okay, so when you download this, it says it's cloning, right? And then what will happen is you'll see it now cloned into your Catkin workspace, right? So all those folders you saw in the browser will now be here. And then you can build it. So there are two commands. So I got a lot of questions regarding this. There's two commands. One is Catkin make and one is Catkin build. So Catkin build is sort of a newer version. And it actually uses some tools from Python. But the only advantage it really has is it gives you more information when it builds a package, right? So you can go ahead and use Catkin Make with no problem. But the thing is, if you use one or the other, you have to stick to it within that Catkin workspace, right? So for example, if you use Catkin Make, then every package in that workspace has to be built using Catkin Make. If you use Catkin Build, you'll have to do it using Catkin Build. So to set up Catkin Build, I think there's an extra step of setting it up. You can just Google install Catkin Build, and you get a link to that, right? But Catkin Make comes default if you install ROS. So I think everyone should just stick to that, right? But I've set up Catkin Build, so I'm just going to use Catkin Build, right? So when I do this, it's going to build all the packages in my Catkin workspace, including the USB camera package, right? There's some other packages in here as well. You can actually pick which package that you want to build, but I picked all of them, so it's kind of building all of them, which was a bit of a mistake on my part, but it shouldn't take this long for most of you. Right. Okay, so everyone following along at home, you can actually try this first step and see if it works on your laptop. So everyone here as well can try that out. Yep. Let's go to tutorial 2. So the command to launch your USB camera is this, right? ROS launch USB cam, USB underscore cam dash test, right? So this is in tutorial 2, right? So once you install the packages, you can launch a USB camera using this command. So go ahead and try it out using your, I'll pass a different USB camera along as well, but you can try it out with your laptop camera. Okay, so now you can see that everything is built. Usually if there's any errors, they'll say over here. Once you do that, you need to make sure you source the bash file, right? So the bash file is basically this file on your system that basically tells your terminal where all the paths to all the important libraries are. So now that you build this, you need to just run this command just to make sure you refresh the bash. Another way of refreshing the bash is you can close the terminal and open it again, right? All right, so once you do that, just run this command. That's in tutorial 2. You can also use tab on your on your keyboard, which will auto-complete the command. Right? So you can see that my camera on the laptop is now working, right? So I'm accessing the camera on the laptop using ROS, essentially. Right? So what this means is now I can, for example, we talked about a certain bunch of ROS commands. For example, if I type in ROS topic list, you can see a bunch of ROS topics now, right? So for example, this image you're seeing now using my laptop camera is in this topic, right? So for example, if I type in ROS topic echo, so these commands, by the way, I covered in the ROS session I did with most of you. So rewatch that video if you don't remember. So if I run this, you can see this is basically my face, these numbers, right? So if you guys remember, a camera image is just 3 matrices with numbers in them, with intensity values. So this, what you're seeing here is my face, right? But if you want to visually see that, you can see it here. I also told you about another command called image view. If you type Rostan RQT image view, you get this command where you can pick different topics that you want to visualize, and you can see I'm visualizing it again using this. Yeah, so this you can do at home, right? Because if your camera has if your laptop has a camera or you have a USB camera, you can try this at home, right? So that's the first exercise. The second is the RealSense. So setting up the RealSense is a little bit more complicated. So the RealSense has a library that you need to set up first, which I've given instructions to here. Afterwards, just like we install the USB camera ROS package, you need to install the RealSense ROS package, right? And that's a similar procedure where you clone it into the repository, clone the repository into your Catkin workspace, and then you build it. But you also need to clone the right version because this library has to always be one step behind the current version right? So there's issues with, since you're working with open source software, there are different versions people have built. So I found the right version that matches up to the current library here, right? So make sure you check out. So checking out means you're checking out a specific version of this repository, right? And after that, you kind of build it, but you have a few more commands to build it in release mode, so usually you can build in debug mode and release mode. So release mode is when you kind of optimize it for release rather than for debugging, right? So just follow these instructions and that will set it up, right? So let me show you what that looks like. I'll actually first show you guys using my camera. Okay, so this is what a RealSense looks like, right? It's actually this bit over here. This is basically the stand which you can take off, right? So if you're working on Turtlebots and stuff, you get RealSenses. By the way, I hope everyone can see me, and I haven't just shared one specific. Can everyone see me? Just to confirm. Okay, cool, awesome. Right, so this is your RealSense. You can see here that the RealSense has two infrared cameras over here, right? So it has two infrared cameras that act as stereo cameras. So you learned about stereo cameras during your theory class. So stereo vision, just like humans, is one way we can obtain depth. So it has a stereo camera that helps it obtain depth. And in addition to that, you can see right here, it has an infrared projector. So it projects a pattern onto different objects, and you must have learned about structured light. So it projects a pattern onto objects, and based on the deformation of the pattern, it can basically calculate depth. So it has two ways of calculating depth. Its primary way of doing it is using the infrared sensors, but it kind of refines the result using the infrared projector through structured light. And then in addition to that, it has a regular RGB camera on it as well, right? So it's a combination of a lot of sensors, right? And you can see here that they are situated in different places. So like, remember I talked about transformations and things, right? So you need to know the transformations between all of these sensors, and that's internally handled by the ROS package, right? So you can kind of combine all the information together. So let's actually run this and see what happens when we do it, right? So I'm gonna stop my USB camera and just launch the RealSense. Yeah, so this is a command to launch RealSense. Okay. Give me a sec. I have a different workspace for this, so I need to. All right, so I've launched the RealSense, right? And if I type in ROS topic list, you can see there's a whole bunch of topics here, including depth information as well as RGB information, right? So let's start off by looking at the RGB information, right? So to visualize it again, I'll be using Image View, which is a tool to help me visualize it. So the name of the topic with the color image is this, right? So when I click that, you can see what the RealSense is seeing right now, right? So these are your fellow students. Say hi, guys. Yeah, so this is the RGB image. And I told you that there are two infrared images, right? So that create the depth. Yeah, hold on. So I've only launched the RGB cameras. Let me launch the depth camera. Okay, first, before doing that, let's look at the point cloud information coming from this. So you can see that you're getting 3D point cloud information. Again, what I'll do is I'll provide a ROS bag from this. I'll get one of the students to record one. But yeah, you can see what the depth information looks like coming out of this, right? So this is a RGBD point cloud, right? Because you're getting the depth as well as the color information from the RGB camera, right? Okay, so let's actually look at the individual infrared images. Oops. I don't know why it's not publishing the individual infrared images. It usually does. Oh, here we go, right? So this is the individual, this is the left infrared image. Can you see the pattern on it? So this pattern is, so it's an infrared projector on this that helps it kind of understand deformations in the environment, right? So it's doing two things. It's using stereo, where it's using two cameras. So this is the first infrared camera. And if I switch to the second infrared camera, you can see that's the second infrared camera. So it uses it like two eyes in that, like we have, and then it calculates depth. And then on top of that, it adds this infrared projector as well, right? But for example, if you take this outdoors, the infrared projector is not much use because sunlight, the infrared light from sunlight kind of floods it out. But it still works outdoors because it has a stereo camera as well, right? So the projector kind of it's like an added layer to kind of refine the final depth result, right? So those are the infrared images. You saw the RGB image, and I showed you guys the depth image as well, right? So all of these can be accessed using any of these topics, right? If you type in ROS topic list, you can see the list of topics that are actually here, right? So this particular camera also has an IMU in it, which is why you're getting gyroscope and accelerometer readings as well. All right, so that's the RealSense. And then finally, the third thing that we'll be talking about is simple LiDAR, right? So let me launch my webcam again. Yeah, so you can see here, this is a 2D LiDAR, right? So you get 3D LiDARs, but this is a simple 2D LiDAR. So it has a spinning thing over here, right? And you can see here that it has a projector and a receiver. So it projects the laser and it comes back and it receives it, and using the time period that it took for the laser to bounce back an object and come back is what is used to calculate the depth, right? So for example, if I plug this in using USB, you'll see that it starts rotating. Hopefully most of you can see that, right? So if I launch the RP LiDAR ROS package, give me a sec. I need to enable it to access my USB port. So yeah, so once you launch that, you can see it's launching RViz, which is sort of another visualization tool in ROS. And you can see this is the LiDAR information that you're getting, right? So this is me, I'm waving right now. You can see the slide change. And then you can see the walls in the room, right? So you're getting this 3D point cloud depth information from this LiDAR. And as you can see, it's not that great because this is a really cheap one. This is, I think, about $200 or $300. But then there's like $4,000 2D LiDARs, which go all the way up to like 50 meters, which are better than this. And then you have 3D LiDARs, which are around $8,000, $6,000, $8,000, right? Which are the ones you see on self-driving cars, right? They have these LiDAR sensors on them. But that's...
I was just gonna ask how the 3D light work.
Yeah, so it has multiple beams.
So is it like a model that moves or something like that, and how the
Yeah, so it has a rotating element and it has multiple beams.
right.
And then it scans the whole thing, right? So the number of beams will determine the resolution of the final point cloud image that you're getting, right? So it will be obviously better than this. So as you can see, this is just on a 2D plane, right? So there is new investment into what we call solid state LiDARs. So instead of a rotating, mechanical rotating device, there are these small chips that can do it. But they've been saying that they'll come out for the last 5 years, but they're still under development. And the idea is eventually they can fit in our phones. If it's a solid state chip, you can just have a LiDAR on our phone, which would help us like map a room or something like that, right? And the new mechanical LiDARs are also getting better and better. They're getting more and more beams and getting more and more high in resolution, right? And that's mostly driven by the self-driving car stuff, right? Because that's a huge industry now and there's a lot of investment going into it. And one of the main sensors that they use is the LiDAR, right? Because it's it's a reliable sensor, and the depth information is super useful, right? Because a camera can't do depth. And you probably saw the depth information coming from this. It wasn't that great. It was like it was kind of messy, right? So there's a lot of noise and things like that in vision sensors, right? But I think personally that ultimately it'll have to be a combination of all these sensors that help you kind of do all that, right? Okay, so that covers all of it. So now what I'll do is I'll pass these sensors around so you can try it out yourself. So we only have 3 sensors. So you'll have to share. I have hand sanitizer and wipes. So make sure you use all that, and yeah, be safe. We don't want to be a new cluster all over the news, right? Saying it started from a bunch of experiments. So everyone back at home, you can ask me questions now. You can try the Rosbags under tutorial 2, which give you RGBD sensor. It's not the real sense, it's a Kinect, right? You don't need to install the Kinect to see the sensor information. So download that Rosbag. If you go to UTS Online under week, basically look at this question. Tutorial 3, question 2, right? So if you go to tutorial 3, it should be under week 3. Yeah, you can see that there is a Rosbag named tutorial_RGBD.bag. You can try that and try the first question with your USB camera back home. All right. And if there are any questions, you can ask me now. I'm just going to hand out the sensors to the people who are here. And yeah, Joseph, I'll come to your question in a bit. Okay, so who set up the RGB cameras again? Who wants to try it with this? This. Who set up the real sense? Yeah. So once you're done with passing, just be careful with these sensors, especially the real sense. Make sure you don't drop it or scratch the lens. And who wants to try the LiDAR? Who's installed the LiDAR? Yeah. So pass this around and make sure all of you get a chance to try all these. Okay, so I'll help you out in a bit. Okay, so Joseph, you say that it won't let you launch USB cam from the Catkin folder. Can you tell me what the error is that you're getting? Okay, so I want you to go into your Catkin workspace and see if you actually downloaded it in this folder. Actually, why don't you share your screen? I'll allow you to share it, and then we can, because what we can do is if we kind of debug these issues together, then everyone will see how to solve them, right? So Joseph, go ahead and share your screen. I've allowed you to share your screen.
Yeah, I have to be the first part as well.
Okay. Yeah. Give me a sec. I'll sort Joseph's issue and then come to you.
Yeah,
Okay, so Joseph is downloading Zoom. Till then, I'll yeah.
first one flash.
Close and open.
Which terminal? If we're doing this, do we have to start ROS call?
So if you're using ROS launch, you don't have to. It automatically starts ROS call as well. You don't have to be inside this.
Oh, okay. So
So let's wait. Just type it out, ROS launch. Space USB. And press tab. Tab. Okay, can you cat in make again? Is your you downloaded the puts the source inside? Yeah. Source dash file. Tab setup. Okay. Okay.
and then
USB.
it's not there. So
Type the whole thing and you put two C's.
Like after lunch.
Dash. Dash. Yeah, good.
all right.
Okay, give me a sec. Yeah, sorry. Okay, Joseph. Typing help is not going to help you. Go into your Catkin workspace, go into your source folder, and show me if you've downloaded USB cam. Should be in home. Yep. Okay, cool. So can you navigate to Catkin workspace and type in Catkin make _make? Yep. Okay, now type source, devil, DEVE, tab, setup, tab, tab, or just type bash, bash, BAS, B for ball. Yep. Cool. Now type in ROS launch, USB, tab, nope, USB _cam. Yep. There we go. What's up, Joseph? Nice beard. Okay, cool. Awesome. If anyone else has any issues, let me know. Now I'm just going to help a couple of students in here. So check out, type in Argus and look at the point cloud. Or go to check out the different
Yeah, I already did.
Yeah, that's not.
Did you want to? No.
Type in, stop your current launchpad.
Oh, wrong.
Joseph, you have to do connect to. Just add a 2 at the end of the thing. There you go.
Because now that's the so use type and but it's fine as long as you can figure out which. Type in this, which will be this. Yeah, in particular.
Use resources as the eye.
Yeah.
Alright, got it. Yeah. I don't know. Like I changed it to. Build it. Yeah, alright. Sorry. Yeah, that one, Alright, easy.
They got the USB.
Yeah, so, like I mentioned, there's two ways to install. If you install it like this,
Yeah.
it gets installed in your system.
Is underscore param, right?
You're using the Ubuntu package manager.
And then you call the parameter.
So do I just run real fast?
Yeah, so this is for the LiDAR.
Yeah.
So, but I'll actually count that. Yeah.
How can you change the parameter in the launchpad?
Yeah, I'll actually cover that because I think a lot of people might be facing that issue. Okay, so what's the shortcut for pace? Control Shift V. On the terminal, you mean, right? Who's sharing the screen right now? Still Joseph? Why installing CUDA? Okay. Okay, so everyone at home, there is no point installing the RealSense if you don't have a RealSense sensor, right? Okay, fam. Basically, okay, if you don't have a RealSense sensor, right, or a LiDAR sensor at home, which most of you probably don't, there is no point doing the second and third question in your pre-work, right? So instead, you just use the ROS bags that I've given and install it, right? Again, you don't have a Kinect, so installing a Kinect is not going to help you if you're at home. Okay, so all you have to do is download the ROS bag, and you do everything from question 2.2 onwards. Does that make sense to everyone? Okay, there are a couple of things I need to discuss now. Esteban, you wanted to talk about launch files as well. Okay. Joseph, can you stop sharing your screen now? Okay, thanks.
Are you showing how to do the LiDAR?
Sorry?
Are you showing-
Okay, so there's two things. I'll get to the LiDAR and I'll get to also. Share the sensors around. Yeah, once you're done, share the sensors around, please, because everyone else has to use them as well. Yeah. Okay, don't hog the sensor, share them around. We have close to 40 minutes more, right? Sorry? Just pass it on to the next, pass it on to the next person. Either you wipe it or the person who receives it. Just don't slather hand sanitize on the sensors too much, right? Just be gentle with it. Don't scratch the lenses and things like that, okay?
How much is it?
Sorry?
How much is it?
The RealSense is cheap, but I need it for my project, so
Oh, right.
it's about $150, but just don't break it because I actually need it. Okay, so first question, how do you edit launch files? And this is a legitimate question because if you have multiple cameras, you need to mention which camera you want to access, right? Whether it's like for example, if you have an external USB camera, you need to make sure that it doesn't clash with your internal laptop camera, right? So how you edit the launch file is you go to the folder that you just downloaded, right? USB cam, and inside there'll be a folder called launch, right? So launch file is basically the command that you type in, right? When you want to launch something would basically access this launch file. So there's two ways to launch a ROS node. You can launch it using a launch file, in which case you don't have to type in ROSCO because the ROSCO gets automatically started. If you want to launch the original source file, you can use a command called ROSRun, right? But it's better to have a launch file like this. The launch file is just a simple text file like this. It tells you which node to launch and what sort of parameters fall into that node, right? So for example, Esteban, can I borrow the USB camera for a second? So right now, I have two cameras with me, right? I have the laptop camera, and then I have the a USB camera in my hand, right? So right now, obviously, when I type in USB cam ROS package, it's launching my laptop USB camera, but I want it to launch this. not the laptop camera, right? So what you have to do is go to the launch file. When you open the launch file, you get a bunch of parameters here. And basically, yeah, this video device is what you want to change, right? So there's a command called lsusb, or you can go into a folder called etc devices on your file, or you can just change this number and see it should be either 1 or 2, right? So hopefully it'll be 1.
Sorry, Million. Would you mind sharing your screen? It's not sharing.
Oh, right. Sorry, I'm not sharing my screen. Sorry. Okay. Okay, sorry guys. So what I was saying was, hold on, let me run through that real quick again. Yeah, I have 2 cameras. I have my laptop camera, which is what's streaming now. And then I have this regular USB camera you can buy for like $20, right? The thing is, when I launch my ROS package, it's accessing my laptop camera and not this camera. So we're talking about how to switch between them, right? So all that information should be in a launch file inside your USB camera ROS package. So every ROS package comes with a folder called launch. Inside, you'll have a launch file, which tells you the parameters that you need to control to launch it. And here you can see, this is where you set which video device you want to launch, right? So for example, if I type in lsusb, to give you the different devices here. And from this, you can pick actually, there should be a different command for video cameras. So you can just can't remember the command off the top of my head. Yeah, so it should be basically this, right? So if I type in this, these are the different video devices that's on my computer, right? So you can see that it's 0, 1, 2, or 3, right? So you can just try 1. Hopefully that will be the correct one. There's also a different folder in your, it's usually in a folder called, yeah, sorry. I think it's dev. Yeah, I don't remember right now. It should be etc dev or yeah, which lists out the devices you have as well. Basically, just Google that. I can't remember off the top of my head, or you can just change this number and see what happens. Okay, so that didn't work. You can try 2. Yeah, so now it's actually using the USB camera that's in my hand, right? Not the USB camera that's on my laptop. Cool.
So basically all the parameter is set in that launch.
Yeah, so usually parameters are set in launch files. You can write your own launch files. So this is the structure of a typical launch file, right? It has the node that you're launching. So this node corresponds to some sort of C++ or Python code, right? So for example, if I go into, if I go into my Catkin workspace, go into USB cam, and go into the source folder, you can see this file called usb_cam.cpp. That's the ROS node that you're kind of launching here, right? And the parameters that you can set are written out here in this launch file, right? So if you don't have a launch file, you have to use a command called ROS run, not ROS launch, right? If you just want to directly run this file, right? If you're running ROS run, you need to start a separate ROS core, right? So you need to type in ROS core here, to launch the ROS master that I described before, right? But if you're typing in ROS launch automatically launches the launch file as well as a ROS master for you, right? In which case you don't have to separately type in ROSCO, but if you want, you can do that as well. All right, so that's how you edit a launch file, and this will be really helpful because when you're playing around with your projects, you will have to edit your own launch files, edit your own code. So get used to going into these folders and understanding what's going on here, right? So the source folder has the actual code on how to access the camera, right? And then the launch folder should have the launch file, which is just a text file, right? Yeah. Okay. Share the sensor around this. You need a different off cycle. It just acquires the sensor data, and then what you do with the sensor data is up to you.
Is it the, like, you guys set from,
No, you get to do all of that. So yeah, you have full control. Okay. One more thing. This is mostly for the people who are here, everyone. If you're going to use the RP LiDAR, there are a couple of commands you need to actually run before running it. Just go into just type in RP LiDAR ROS, right? Right, and go to the first link that you get, and basically run these 3 commands first, right? So what that does is it sets what we call the UDEV rules. So it sets a link to your USB. Once you plug in the device, it gets a shortcut attached to it within the USB device list. So you kind of permanently set that. Or you can kind of type in this command, which will also give you write access to the USB device. And then you just need to launch this, right? So this is for the people who are here, right? Once you start using the RP LiDAR. Guys, share the sensors around
So just confirm.
half an hour more. Yeah.
So that means I have done the real world installation.
Right.
Right? So what I have to do, you know, okay.
Yeah. Make sure.
There's a way we can do like this, right? So we can change from the
Yes.
Sure.
You need to say
Also parameters of the
you can go into go into launch. Google passing parameters.
Yeah.
Did they say parameter?
yeah.
What's the error? I think there's a difference between arguments and parameters. Yeah, I think it's just.
I think it's only on both,
Probably on usually around 10.
Yeah, like. It kind of looks like every fucking time I go to the I was so.
Yeah, I have to spend some time. Yeah. Guys, can the sensors please?
I do always see how you can like. Yeah, there's so much of that. Yeah, well, see, I'm only finding out that like office versus on, that there's all this extra shit we have to do with this stuff. We're getting our marks back today. Yeah, they said they're going to tell us before, before, 8 p.m. and do to. Yeah, so I was trying to do this one, and then this one actually uses like you know, the good part directly. So I then try to do this setup. And it's going to do it. Which is this project. What's that? Yeah, I don't know why. Overwatch. Yeah. Sometimes you do it, sometimes you don't. And someone did that, did Google it, and then that and do it and try to see.
No, I didn't work. I had to send it to the passed around.
I, yeah, so can you install this? So Python sudo. And then DB. Basically, you have tab again. Yeah. Device. Yeah, that's fine.
So he's got it? Okay, so
Yeah, there's a real sense. Okay, back to you on any other questions? Everyone back at home? Esteban, you're using the real sense, right? Could you, so if you go to the real sense viewer, no, not the real sense viewer, if you go to the real sense ROS data, there should be a command to launch the point cloud demo. Can you do that and then record a small not 2 weeks long, maybe like 30 seconds to 1 minute. And then give me a transfer. Maybe look around. Everyone sees the left and you can even type on your terminal. No, I mean to figure out the command. Real sense. And then categorize. There should be one. Do the RS RGB. We have multiple categories. You install the real sense, right?
Yeah.
yeah, the error. When I go to the next step, I don't know why. I tried it in on the VRM last night. It happened the same thing. Like the previous error and this error.
You checked that with the correct one.
Yeah.
You set up the library, right? Real sense viewer works, right?
Yeah.
Yeah, you should.
This one, right?
Can you start from the beginning or maybe delete it again? And, as in just list it.
From here.
Yeah, try that again.
So delete from and then.
Yeah. Go into the captain folder, delete it, and try it again. Anyone have any questions? By the way, sometimes the word clone doesn't work if you copy paste it from the document. So just type it in yourself. I don't know why. Yeah, guys, just use tab complete because that reduces the chances of you making typos, and try to copy paste as much as possible. Yep. These are just warnings. So yeah, these are just warnings. just type in Roscovic this time. Install the terminal. So open image tree.
Only different colors.
Yeah, this format probably. Try to point out demo. Yeah, go into on real. Yeah, so
Oh, there we go. That's
let's type in this. Is the
all right, there we go. Yeah, I have it.
once you get it working, you can record it off there. For about maybe 1 or 2 minutes. Just hold it up. And then we can all right, everyone back home. I will be recording some Rosbags from class and I will upload them after the second session is done so you can try them out at home. But until then, there are already Rosbags that are on, as I mentioned, on UTS Online. Okay, so some of you are having problems. Okay, people who are getting this error, just make sure you source your bash file, right? And maybe try cloning it again, building it, and make sure you source your bash file. Or close your terminal and restart your terminal. Did everyone get a chance to test at least one sensor? Sorry?
Our RGBD is not that one the one on Facebook, the other one works.
The point again.
No, that one works. But the other one, it didn't work. No one works. But the RGBD, that one doesn't work.
So yeah, usually whenever you set one of these things up for a project, you wait like a day or so to debug and figure it out.
So we wanted to record the Rosbach for the RGB demo, the point cloud.
Yeah. So basically, if I think you can't record all the topics because some of the topics you saw like the compressed topics. So if you can record the RGB image, depth image, and the point. And should be good. You said the infrared image is on the topic.
No, that one's a problem.
So getting those things.
Is it?
That's what I mean. Like, all this copy paste, all this background.
Yes.
How do you also work on the?
All right. So for those of you who want to learn how to record a ROSBAG, it's just a very simple command. Once you have everything running, right? Just type in ROSBAG record. If you want to record all the topics, you type in ROSBAG record -a, and that will record everything. If you want to record particular topics, you have to list them out here, right? You can also create your very own launch files to record stuff, right? So a simple example of a launch file to record. So even the ROSBAG record is a separate node, right? So for example, if I go into launch file, yeah, so here you can see that I've created a launch file just for recording topics that I want, right, in my project. So I've started the ROSBAG record node, and I've listed out the topics that I want to record. Okay, so or you can just simply type it in your terminal like this, right? Just ROSBAG record minus a, if you want to record all the topics. Okay, so just to deal with some of, okay, Joseph and Trong. Joseph, I got yours working before, so I don't know what you did to mess that up. Trong, can you share your screen? We'll try to sort out Trong's issue, and then maybe hopefully Joseph can sort out his as well. Okay, awesome, Joseph. Good job. Okay, Trong, do you want to share your screen? Yeah, Trong, can you try that as well? Just close your terminal, resource it. By the way, I'm getting 2 students to record some ROSBAG, which I'll upload after this class. That is in another 10 minutes.
Oh, it's not working. I think the setup.
Okay.
Yeah. Is that it?
If you're going to use a RealSense, you might as well try it. If you're not using a RealSense, it's okay. Try doing it without checking out the tag. Just git clone. Keep this one.
And then it goes back to
Yeah. Go and check out version 2.2.5. Do this and run. But you have to delete it again. Okay, so to choose the camera, go into your launch file, right? So it should be in this folder USB cam, and inside the folder called launch, there should be your launch file. Open it, and you can see that there is a parameter name that you can change. You can basically change the device value here, right? So yours probably has the default 0. You can try 1 and 2 if you have multiple other cameras, right? And if you want to see what other cameras you have, there is this command over here, or you can just Google this command to see what devices that you have. Yeah, so you just change it in this text file. So originally it was 0. You can try 1 and 2 because you can see here that I have all these different devices, right? So each launch file will have, I don't know what you're saying, Joseph. So each launch file will have different parameters that you can control. So this is these are the parameters you can control for your USB camera. If you look at a RealSense launch file, this is what it looks like. You can control a whole bunch of other parameters, right? So yeah. Okay. All right. So maybe moves around.
So what could be the problem? So what could be the problem? Like, why is that? What is the reason behind it?
I don't know.
Then we have to
Yeah, I have a sensor bank here. So usually whenever you set up a sensor, we have a bunch of equipment and you have to spend about 1 day to debug. So think about that when you're doing your project as well. The video itself you have time to debug because every computer is different. So there will be problems, but you have to then Google those problems. Yeah. This is normal. So whenever you're working with people, but if I have more time, and probably not be out of time. Guys, we're out of time now. Sorry? Yeah. So both of you have the lost leg. It works, right? The lost leg. Yeah. Not great, that. Do the same two lost legs. Right. That's I told you 1 minute because yeah, like I have lost legs. Like 500 GB or 1.5. So the second file that you had, yeah, just rename it as real sense lost leg or something, and then from both of you we all have like if you all have one, that's good enough. You have one? Can both be copied? Yes. And stay about 10 minutes after that? Yes. And then, yeah, because you'll have to use my computer to upload it on this online. Okay, everyone else, time's up. Thanks for coming. Make sure you return the sensor. Can you keep the sensors over there along with the wipes and the hand sanitizer?
I already put
Okay, good.
the light one.
Okay, thanks a lot.
Okay, sir.
Okay, so I'm going to stop recording the session, but I'm going to keep the live stream on. So if you all have any more questions, you can ask me.